welcome back. In this video, we will talk about rounding significant figures. I also did a video on how to identify significant figures, so check that out. Let's begin. The best way to learn on how to round significant figures is to do some practice examples. In this first part, we will round off each number to one significant figure. We know that 1 is a significant figure because it falls under the rules that states all non-zero digits are significant. We know that 2 is a significant figure. We know that 7, 3, and 5 are significant figures. Now they want us to round this to one significant figure. And I like to do this in 2 steps, especially if you're new to this subject and practicing will help you out. So I like to do it in 2 parts, and eventually once you master that, you can do it just by looking at it in 1 step. So first, I will convert this to to a number with only one significant figure. We know that 1 is a significant figure, so everything else needs to be converted. But before I continue, I need to know if the 1 stays a 1 or moves up one number into a 2. And the way we do that is just like in your regular math class, you look at the number next to it. In this case, it would be the 2. If the number is 5 or greater, then the number goes up. If it's 5 or less, then the number stays the same. In this case, the number next to the 1 is a 2, which is less than 5. Therefore, the 1 will stay the same. And for the purposes of significant figures, I'm just going to replace every other number with a 0 to make things easy. So step 1 is complete. My one significant figure is right here. But our final answer cannot be this whole thing because technically all these zeros are significant because they fall under the rule that states all non-zeros are never all zeros are never significant except when a decimal is present. And here we have a decimal. Therefore all these zeros are significant, if I was to leave this like that, I would technically have 1, 2, 3, 4, 5 sig figs. But I just need one significant figure. So to do that, I would just leave my answer as 1 with a dot and dismiss all the zeros, or I can leave my answer as 1 without the dot. Either way, you have one significant figure, whichever answer you decide to input. Now for our next example, we have here a few zeros, and then we have our first significant figure, which is the 2. We know that the zeros that are in front of the first non-zero digit, they are called leading zeros, and leading zeros are never significant. So in step 1, I will, however, keep the zeros because they serve as placeholders. So I can't just delete them like I did in the first example. So here we have the 2, and the 2 is the first significant figure. And I have to look at the next number, the 5, to determine if it stays at 2 or it goes up to a 3. In this case, we have a 5, so the 2 becomes a 3 because that's what happens when we round. and I will replace everything else with zeros, and that's step one. Our goal is to convert that to one significant figure, and our one significant figure is the 0.003, because these zeros don't count and only this 3 does count. But we need to keep these zeros because they are placeholders, because these are the tenths, these are the hundredths, and these are the thousandths place. So we need to keep those zeros because they are placeholders. So our final answer will be, and that is one significant figure. In our third example, we have the number 3,836 and 9 tenths. So we know that the 3 is significant and we need one significant figure. So everything else will become 0. But first, I must look at the number next to the 3, which is a 8. So the 3 becomes a 4, and everything else, I will replace it with a 0. And then I can go to my last and final step. All I need is one significant figure, which is the 4. But the 4 means 4,000. This whole overall value is 4,000. So I can't just write 4. I have to keep those placeholders. And I'm going to keep them. I'm just going to keep the 3 zeros. And I'm going to dismiss and omit the decimal with the remaining 0. Because if I leave the decimal, then all these zeros will become significant. But without the decimal, they are not, these zeros are not significant. So I only have one significant figure, and I did not devaluate the overall number, and it still says 4,000. So my final answer is 4000 without the decimal and without the last 0. Now I will do some additional examples with the same numbers, but this time we will round them to two significant figures. This way you guys can see the pattern that is happening, and you can develop your own method as to how to round significant figures. So we know that the 1 is significant, but this time we need two significant figures. So I have 1 and I have the 2. And I look at the number right next to it. It's a 7, so this 2 will become a 3. So I'm going to have 1.3, and I'm going to turn everything else to zeros as my step 1. And I just need two significant figures, which are these two, and I'm going to omit all of that. So my final answer will be 1.3, and that is two significant figures. In example 2, I have the leading zeros, which we already determined that they're not significant. I have my first significant figure, the 2, the 5, and that's all I need. Now I look at the 3 only to determine if this 5 will stay a 5 or go up. Since the 3 is less than 5, the 5 stays. So, and I'm going to keep the leading zeros because they're not significant, but they do serve as placeholders. And I'm going to replace everything else with 0 because I don't need them. And my final answer will be 0.0025. And I'm going to omit these zeros because those zeros are significant because the decimal is present. And I need two significant figures, not six. So my final answer will be, and here I have two significant figures, and I keep the zeros as placeholders. In our in our third example, we have 3,836 and 9/10. We know that the 3 is significant, the 8 is significant, and I have my two stick fix right there. I just look at the 3 to determine if the 8 stays at 8 or goes up to a 9. In this case, it's a 3, which means that the 8 stays in 8. So I have 3,008. I replace everything else with zeros. And my final answer will be, considering I only need two sig figs, my final answer will be the 3,800 without the decimal. Without the decimal. Because if I include this decimal in this answer, then I would have four significant figures. And I do not want four, I only want two. So I'm going to omit the decimal, and the zero gets omitted. And in here we have two significant figures. And lastly, I want to do one with three significant figures, and this one will do a little bit more faster because it's the same numbers. We have the 1, the 2, and the 7. So I'm going to keep the 1, the 2, and the 7. I look at the 3 to determine if the 7 stays the same or it goes up in value. 3 is less than 5. So everything else I replace with 0. And my final answer will be 127 because in this example they want three significant figures. So my final answer is 1, 2, and 7 without the zeros. And in here we have 1, 2, 3 significant figures. I look at the 6 to determine if the 3 stays the same or goes up. The 6 is greater than 5, so the 3 will become a 4. So I'm going to set it up in step 1. 2, 5, 4, and everything else I'll replace with a 0. And my final answer will be without the zeros. So 0.00254, and I have three significant figures. And in the last example, I have the 3, the 8, and the 3. I look at the 6 to see if the 3 goes up. It stays the same, 3,830. The 6 tells me that the 3 goes up to a 4. I only need 3 sig figs, and I need this 0 because it's a placeholder, and I have to omit this decimal and 0. So the answer is going to be 3,840, no decimal and no trailings, and no 0 after the decimal. I hope you guys enjoyed this video. Please like and subscribe for more.